Hello everyone, welcome back to the channel, and today as always we are going to continue developing the chess game, which we have been doing so for the last couple of videos in Unity. And this is the point where the coding is going to get a little bit more complex. I'm going to use a few paradigms which might not be common to a novice programmer, but yeah, they are quite widely used, namely bitwise operators and bitwise operations. So let's get right into it. So this is where we last left off, and now if I run my code, this board shows up, the pieces are all spawned on the board, and I can actually move the pieces about. But as you can see, there are a lot of problems. The game doesn't know what player's turn it is. I can literally pick any piece and I can move the piece of the same color on the very next turn. So that is an issue that has to be fixed. Also, there are no legal moves so far. I can move any piece in any way I want. So that is another problem that we have to fix. One more problem, we actually don't know what piece we are selecting when we are making the move. Like for example, if I'm moving this pawn and I move it to attack the king, then I have no idea to actually check whether the piece I moved is a pawn, or if it is of any other type, or even what color it is. So first thing, we need a good way to represent each piece in memory. So what I mean by that is we need a way to tell what type of piece it is and what color piece we are actually moving. And also we need a good way to represent the board and the position, whatever position is taking place in the current game we are playing. So two things, we need a good way to represent the board in memory and a good way to represent each piece in memory. And we are going to take a look at how we can do that in this video. So first of all, we need to create a new class, and that is going to be the chessboard class, which is going to help us represent the chessboard. But before we actually work on that class, we are actually going to work inside the piece utility class and represent how a piece might look in our chess game. So if we go over here, and I have this piece utility class opened up, and inside public static class piece utility, we need a few things. First of all, we need to check what type of piece it is. So we need a value, or rather a mask, to check the type of piece. And okay, so first of all, we need so I'm just going to say this: a piece is going to be represented by an integer, the in a bitwise, in a two binary, let's say, okay, let me just type this out: public constant int type mask. And this type mask is going to help us determine the type of the piece. So if a piece is 5-bit long, the first 3 bits are going to be the type of the piece, because the first 3 bits will tell us that is all that is required to know the type, because the highest value piece is the king, which is of value 7, and 7 can be stored in 3 bits. So 4, 5, 6 and 7 is the highest value which can be stored in the 3 bits, and the next 2 bits are going to tell us what color of the piece it is. So the type mask is going to be OB. That just means that we are writing the code in binary. This is going to be the type mask. We also need one for the black mask. So black mask is going to be OB10000, and white mask is going to be OB01000. So these are the 2 masks we are going to use, and we can have one more, which can be public constant int color mask. So this mask will tell us what color the piece is going to be. So this will just be black mask, and this is the bitwise OR operator. So this will just give us a bitwise result of ORing each bit. So for example, if we do black mask or white mask, then the value of this will be OB11000. This is because if we OR these 2 values over here, or 0 and 0 or is 0, same with here, but over here 0 and 1 or is 1, and 1 and 0 or is also 1, so this will be 1 1 0 0 0. So this these are the four masks we are going to use. Now we need a function to actually apply these masks on the value of an value of a piece. So a piece is going to be an integer. So let me just make a new region for this. Region public functions and region. So the first function is going to check the type of the piece. So let me just flesh out this function. Public static int, let's say, and this is going to be piece type, and this is going to take in as input the value of the piece, and this will just be return, and we are just going to check the piece value, and we are going to AND it with the type mask. So this should give us the type of the piece. And let me just make sure that what I'm typing is correct. This code is just for reference. So yeah, now next we need a function for the color of the piece, and quite similarly we can do this by, I'm going to call this function piece color. This is also going to take in as input the piece, and we can just do return piece and color mask. So this will give us the color of the piece. Now we might also have a case where we want to verify if a piece is of a certain color. So let us quickly make a function for that. Public static boolean, this is going to be a boolean. It is going to return either a piece is true, it is of that color which we are checking, or not. So bool check color. So this is going to take in two parameters, one for the piece and one for the color we want to actually check. So these are the two parameters it's going to take in, and how it's going to do that is it is going to check if it is going to check the color of the piece. So it can do that by the function we have just declared, piece color piece, and it will make sure if this color is equal to the color we are passing in, and we can just return. This will check whether a given piece is of a certain color or not. So that is going to be it for now for the piece utility class. Let me just check if I'm not missing anything. Yeah, this should be good for now. Now we can move on to the chessboard class. Now the chessboard class is going to be quite complex, but I urge you that it's not difficult, and just follow along, and you can rewatch the video if you get stuck or don't understand any point. So this is going to be a standalone class, so we don't need mono behavior. We can get rid of all these lines of code, and let's just keep these three lines in for now. So the first thing, the chessboard is going to need how are we actually going to represent the chessboard? So if we go back to the Unity editor, and let me propose a way to represent the chessboard over here. So we are getting an error. We'll fix that quickly. It is in line 28 in piece utility 28,16. You cannot apply the AND operand on two ints. So what are we doing wrong here? I'm pretty sure it does work like that. Okay. So this isn't actually the bitwise AND operator. This is the conditional AND operator. I think that's what it's called. Basically, it checks whether one value is true and another value evaluates to true. Then the entire value will evaluate to true. This is the bitwise AND operator, which is what we want, similar to the bitwise OR operator we just used over here. So now it should get rid of the error we were just facing. And type doesn't exist in current context, piece utility 24. Piece and this is supposed to be type mask. So that is fixed. And I think We are good for now. Okay. So now if we run the code, yeah. So this is the chessboard we have. Okay. So what I'm going to propose is, and this is a common way to represent chessboards in the world of chess programming. The bottom left square, which is the white rook square, the A1 square, will have the index of 0, and will go by increasing 1. So this will be 0, 1, 2, 3, 4, 5, 6, 7, 8. And the top right square will have an index of 63 because the chessboard has 64 squares. What we might want is an array of 64 values, each one representing a square of the chessboard. And if let's say the first square has the rook inside of it, then that value in the array will be occupied by the piece value, which we have just made a few functions for in the piece utility class. So that is how we want to represent a chessboard in our chess game. So if we go back to the chessboard class now, what we might want is a public int array, and this is going to be called position to represent the position of the chessboard. And what we might also want, uh, let's say public int, rather public bool white to move. So this will just make sure whose player's turn it is. And public int color to move. This will just tell us which color's turn to move it is. Then we want a few indices, public constant int white index, this will be 0, public constant int black index, and this will be equal to 1. Something else which we might need is, let me just go ahead and check. So ignore this for now. This is a lot of code, and this our chessboard function will eventually look like this: white to move, color to move. And yeah, we also need a public int for the opponent color, public int opponent color. And do we need anything else? Color to move, opponent color, color to move index, and opponent color index. Okay, so we need color to move index and public int opponent color index. So these are the few fields which we might need. We will need a lot more, but for now these are okay. And also we want a way to store the location of each of the chess pieces. Like we want our array to store the location of all the knights, one to store the location of all the rooks, the bishops, the queens if there are multiple, and also for the pawns, and also one entirely separate variable to store the position of the kings, because the king is the most important piece in chess. And yeah, so I think it deserves its own variable. So we are going to create a new class in the piece utility C# script, and we'll be calling it piece list. And what this piece list class will do is store the location of all the pieces of that type. It will give us an easy way to add another piece. If, for example, if you promote a pawn to a rook, then a new rook will be added to the piece list class for the rooks. And a easy way to remove the pieces if they are captured, and a good way to move the location of the pieces if we make a move with that piece. So let me just copy down this line of code for the piece list, and then we can just I'll just walk you through it one by one. So piece list, and we'll just copy this down. Okay, and just a second. Yeah, okay, this should work. So public class piece list, so this is going to be a list of integers. And yeah, so this is going to be a list of integers. The Okay, let me just change this to capacity. Yeah. So this is a constructor for the class. This will tell us how the piece will get, yeah, the piece squares array will get initialized, not an array, or rather a list. Then what we want, okay, so this is a function to get, it just returns the number of pieces in the piece list. This is a way to insert a piece inside the piece list. So piece squares dot add, and add is a function which is given to us due to the list class we are using. A good way to remove this is a way to move a piece inside the piece list. So what we are doing over here is we're accessing the piece squares list. Then we want the index of the start square, because that is where the piece is located, at the start square. We want the index of the start square, and then we are going to replace start square by the target square, because that is where the piece has moved to. Then this is just a try peek function similar to a stack. And yeah, I think that is it. Let me just fix the indentation. Okay, that is it for the piece list class. So this is going to help us. So it has three main functions: insert piece, remove piece, and move piece. And these are going to be super helpful. So now what we might want to do is create a piece list for all the different chess pieces in the game. So for example, what we have over here is a piece list for all the knights, the bishops, the rooks, the queens, and a universal list for all the different types of pieces in the chess game, and one array of integers for the kings. So we might want to copy down these lines of code and just paste them over here. So hopefully this makes sense. And now what we want is a constructor for our chessboard. So public chessboard, and this is going to take in as input the square count variable. So square count, and we might also want a public int square count. So first of all, we want to initialize and pass in the square count variable. This dot square count is equal to square count, and this is necessary because it's required to initialize the positions array. So position is equal to new int, oh, pardon me, square count times square count. Okay, and what else do we need? We also need, let me just check once again, king square is equal to, yeah, so we need this too. And okay, so we need this king square and these lines of code. So let me just copy these over and we'll go through them one at a time. So first of all, we are just initializing the square count variable by passing in the parameter. Then we are initializing the positions array, which is the position of the chess game. Then we are initializing the variable which is storing the position for the king. And then we're initializing all the different piece lists that we have declared. So a knight square, this is going to be an array of piece list, because one for the player and one for the opponent. And a maximum of 10 knights can be in a game, because 2 knights are already present and 8 can be formed by promotion through via a pawn. So a new piece list of 10. So same for bishops, the rooks. Queens can only be 9 because there are 8 pawns and 1 queen, and pawns can only be 8 because there is no way to get extra pawns in a game of chess. The all piece squares piece list array is going to contain the array for all the different pawns, knights, bishops, and all the other chess pieces in the game. So these are null because of a very specific reason, which will get revealed in due time. But for now, just stick with it, copy down this line of code, and I'll promise I'll explain it quite soon. So so this is in the same order that we have the prefabs. So pawns are first, the knights are followed by the knights, the bishops. The next space is actually empty. Then the rooks, then the queens. Uh, then we actually don't want anything for the kings, so that is why this is empty. Then again, this is null, and then the same logic over here. So that is that. That is the constructor for the chessboard function, for the chessboard class rather. Next, what we need is, uh, let me just go over these few lines of code. Okay, yeah. So what we need is, what we now want is a way to actually, we are going to discuss a completely new topic, and this is called as fen strings. So what is a fen string? Let me just copy over this line of code. So serialize field at the top of the chessboard class. So this is a fen string, and this string in theory contains all the information you need about a chess game. Or rather, I think this is enough for this video, and we'll discuss fen strings in the video just after that. So just for not making this video too long. So in this video, we created our own chessboard class, and this class we can now actually make our own chessboard game object, which can be in the game manager. So chessboard, we'll just call this as board, and we can actually initialize this chessboard right now in the start function. Board is equal to new chessboard, and this takes in as input the square count. So square count is, I'm pretty sure, 8, and we don't actually have a way to access the square count outside the board UI class. So let's make a static function for that. Public static int square count get return square count. So this will help us quite a lot. So if we go back to game manager now and board UI dot square count, so this will initialize the chessboard game object for us. And in the next video, we'll take a look at how we can use these fen strings to load a position looking like this into and fill in all these fields of the chessboard. And then we can actually take a look at this ugly spawn pieces function, fix that, remove that function entirely, replace that by two lines of code in this generate board function, and we'll take a look at how we can tell the game to know which player's turn it is, if the piece which is moving is of the right color or not, and so on. So that is all. That is it for this video, guys, and I'll see you guys in the next one. Peace.